We can try going to higher frequency to see what happens, but it's much more interesting to actually use the sweep mode of this generator. So we go to sweep, and we have it on log mode, which makes plots that look nicer. We have the start set at 10 Hz where we were. We have the stop set at 1 megahertz, relatively high frequency. And the sweep time we have currently set at 0.1 seconds, 100 milliseconds. Now if we go up and look at our scope, I have very cleverly set my scope up so that its sweep time is 10 milliseconds per division, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions, so it's 100 milliseconds, so it's sweeping right across once every 100 milliseconds. And I have the horizontal offset, see that offset setting, set to 50 milliseconds, so it's offset to start the trace over on the left here in supercross. So we can see low frequencies coming in, they get faster and faster and faster, and our input, although our input stays the same size all the way up, which is good to check in case something happens to our input. At 1 megahertz, our output is clearly reduced by quite a bit. It's reduced a lot. And what we're seeing here is what we call a 3 dB roll-off for our amplifier. Our amplifier goes well up to a certain frequency, and then it starts to roll off with a linear slope as we go up in log frequency. It's actually not really. It's only linear if we have log amplitude as well. But you can see it decreasing quite a lot as we go to high frequency. And an interesting thing to go to is to look at where the half power frequency would be. A half power means that the voltage is actually about 0.7 or the square root of 2, because the square root of 2 times 2 gives you 2. So our V, since power is proportional to voltage squared, if we can go to the square root of 2 of voltage, we get half power, and about 0.7 looks like it's somewhere up here. We're on a log scale here. It's a little tricky to work out exactly where that is on the frequency response, but it's up somewhere up near the megahertz frequency. We can work it out more exactly by switching back to sine wave mode. Turn off sweep. Hit the sweep button. Go back to sine wave mode, and let's go try some frequencies. So let's try 500. It's an amplitude. I want to see. Oh, I'm doing amplitude. I didn't want to do amplitude. Cancel. Press cancel. Where is the cancel button? Can't see it. Cancel. There it is. I want to go to frequency 500 kilohertz. There we go. So now we've whipped up to 500 kilohertz, and our amplitude is 0.6. It was 9 before. 0.6. It looks like 500 kilohertz is pretty close to 0.7. So that's a fairly good estimate. We could play around with it some more, go down here and change our frequency and try to get closer to 0.7. It probably would be a good idea to set the low frequency to go to 10 Hertz. Set the low frequency amplitude. Go down here to amplitude. So our low frequency amplitude is something that's easy to do the math with. So let's turn off trace 1. It's moved.